So today we're going to be looking at 2009 AMC10A number 21. So here we have a ring of 4 congruent circles, and they are circumscribed by a larger circle. And our job is to find the ratio of the sum of the areas of the 4 smaller circles to the area of the larger circle. Okay, so I'm going to connect the centers of the 4 circles. And we have a square because obviously the circles are all congruent. So the square would equal, well, the side length of the square would equal 2 times the radius. So that portion would be, let's just say r. This portion is r2. And the whole side would be 2r. Okay, so drawing the square will actually make it easier for us to compute the radius of the larger circle. So, let's just call that radius, uppercase R, okay. Okay. So if you look at it, uppercase R actually equals 2 lowercase r's plus, let's just call that x. So x is the distance between the edge of the circle and the center. Okay, so to solve for r plus x, we see that this is actually a lowercase r times lowercase r squared, and obviously, let me just use a different color. Okay, so that's a 45, 45, 90 triangle, and obviously the hypotenuse in this type of triangle is square root of 2 more than the legs, so r plus x is also equal to square root of 2r, lowercase r. Okay, alright, so r plus x equals square root of 2r. X would equal square root of 2r minus r, or r times square root of 2 minus 1. Let's just put some parentheses. Okay. Now that we know what x is, we know that uppercase r, or the radius of the larger circle, equals r plus the quantity of r plus x, which is also, let me use a different color. Okay. So, r plus square root of 2r, which is r times square root of 2 plus 1. Okay, so that's what r equals, uppercase r. Okay. Okay, so what we're solving for is the ratio of the sum of the areas of the 4 smaller circles to the area of the larger circle. So that's 4 lowercase r squared over uppercase r squared. And we've already solved for uppercase r. So this is 4r squared over r times square root of 2 plus 1. That whole quantity squared, and obviously these are circles, so we need to add a pi. Okay, so 4r squared over pi over 3 plus 2 square root of 2 times r squared pi. Okay, so obviously that's going to cancel out, and we're left with 4 over 3 plus 2 square root of 2, and obviously we can use the discriminant, which is 4 times 3 minus 2 square root of 2 over 3 plus 2 square root of 2 times 3 minus 2 square root of 2, which is a, this is going to result in a difference of squares, so it's basically 3 minus 2 square root of 2 over 9 minus 8, and that is 12 minus 8 square root of 2, or we can factor it like that, which is C. Thank you.